In the previous clip, we've seen the singleton and object pool creational design patterns. In this last clip, we're going to look at two more patterns, the template method and factory method patterns. First, let's look at the template method pattern. The case study I'll use is connecting with and querying a database. Assume that our system can use a few different types of databases. The process of connecting and querying a database is always the same. We first connect with it, then we query it for the data that we need. However, there's some variation in how connections and queries are formatted for each database type. This is what the code could look like. Of course, as we have learned in the previous weeks, we want to encapsulate variation. The template method can help here. The idea is that we define the skeleton of an algorithm in an operation, but we defer some of the steps to subclasses. You can then redefine steps of the algorithm without changing the algorithm's structure. This is what the template method pattern adapted to our database case study looks like in UML. There's a doQuery method that provides the overall flow of the algorithm, and it uses different format connect and format select method depending on the database that is used. Here you can see an example of what the body of doQuery might look like. It defines the overall structure of the algorithm and calls abstract methods format connect and format select. Subclasses of query template then provide specific implementations of these methods. Basically, you're doing a CVA in your own code. You try to identify the common parts of your code. These go into the abstract class. The variations go in the concrete subclasses. Here's an overview of the template method from the Gang of 4 book. The template method allows for different definitions of the substeps of an algorithm. The algorithm itself is defined as a method in an abstract class. The substeps are abstract methods and are implemented in subclasses. And here you have the generic UML structure of this pattern. Now we again have to deal with creation in some way. Even though the template method pattern showed how to handle variation in databases, who creates the database object that is used? If the database that is used depends on which template subclass is used, then these subclasses should be responsible for creating their own database. So, you can add another method called makeDatabase that does this. Now, the query template class doesn't know which database is created. It just knows that the concrete subclasses will have a method that creates an appropriate database. This is called the factory method pattern. In the factory method pattern, you define an interface for creating an object, but you let your subclasses decide which class to instantiate. This is an example from the Design Patterns book. There is an abstract product class that has one or more concrete product subclasses. Also, there is an abstract creator class that has a makeProduct method. The concrete creator provides an implementation of this makeProduct method to create an instance of a concrete product. What we've seen in the design process now is that we have a part that is about identifying which objects there are based on responsibilities. We've seen several useful tools for that, such as CVA, analysis matrix, noun-verb analysis, and the GRASS principles as more generic guidelines. Design patterns help us create well-designed connections between these objects and determine how they are used. Finally, creational or factory patterns help us decide where objects are created and how they are managed. And as always, the philosophy behind factories is that they help separate creating objects from using them. The using class shouldn't know which concrete class it's actually using. It should program to an interface, not an implementation. The creating class, on the other hand, or the factory, is not concerned with how the objects are used. It simply creates them on demand. Most changes in requirements affect either the usage of an object or a system or the choice of which objects to create. For example, if you have a sales order system and you want to add another country, you need to change the factory part of the software. If you want to add a discount depending on the total order price, this requires changing in the using part of the software. So to conclude, here's the golden rule for object creation. Make a class responsible for using or creating, but never for both. We've seen a lot of tools for analyzing and designing software in this course. As a software designer, it's important that you keep your eyes open. Things change fast in the software world, and new programming languages and development processes appear all the time. Always keep experimenting to learn new things and become a better software designer in the process. We've reached the end of this clip. This is very sad. That's not COVID-19. I'm just having an emotional moment. Perhaps we will see each other again. Perhaps this is the last time ever. Perhaps we will just die at some point. Maybe at least our graves will be on the same graveyard or something. We can hold on to that. But wait, we will see each other again at the final exam of this course. That will be a lot more fun for me than for you. Good luck with the preparations and see you there.